Hello everyone. Today I'm going to talk about one of the most manufacturing processes, which is machining. First thing first, my name is Muhammad Anas Syabudin bin Shahrin. My student ID is 0412504001. Let's go into introduction to the machining. Machining is a process where we remove materials from a workpiece to shape it into a desired size and form. It's usually done using tools such as letters, milling machine, drilling machine, or even a CNC machine. The main goal of machining is to produce precise and accurate parts with a smooth surface finish with a smooth surface finish. The process involves cutting, shaping, drilling, or grinding a piece of metal or other material until we achieve the final product. So machining is a subtractive manufacturing process. Meaning we start with a large piece of materials and gradually remove unwanted parts. This is different from additive processes like 3D printing, where we add a layer to create a shape. So let's go to the importance of machining. Machining plays a very important role in almost every industry. It used in the automotive, aerospace, electronic, construction, and even medical equipment. For example, in the automotive industry, machining is used to produce engine blocks and crankshaft, gears, and brake components. All of which require very tight tolerances. In the aerospace industry, machining ensures that components like tur- turbine blades and landing gears are accurate, durable, and lightweight. One of the biggest advantage of machining is it precision. Parts made by machining can have tolerances as small as a few microns, which is very important for components that must fit together perfectly. Machining can be used for both prototyping and the mass production, and making it a flexible process that support in almost every manufacturing needs. So let's go to the common defect in the machining. Even though machining is highly accurate, defect can still occur if the process is not controlled properly. Look at some of the most common defects. We see here we have five common defects. First we have tool wear. This happen when the cutting tools become dull after continuous use, and when this happen, the surface finish becomes rough and dimensional accuracy decreases. And the second is chatter marks or vibration mark. These are irregular patterns left on the surface when the machining or tool vibrates during cutting. It often occurs due to incorrect speed and feed rate or poor clamping of the workpiece. And the third one is the burr formation. Burrs are small, sharp-edged or unwanted materials that remain on the workpiece after cutting, and they can cause problems during assembly and need to be removed through the deburring processes. And the fourth one is the poor surface finish. This can be caused by a wrong cutting parameters or dual tools or using the wrong coolant. Poor finish can affect the part performance, especially when the parts slide or fit together. And the lastly is dimensional errors. So this happen when the final product doesn't match the specific dimension, and it can be caused by tool deflection, thermal expansion, or human error during measurement and setup. So let's go to the quality inspection and the control method. So to make sure that defect don't reach to the customer, manufacturers are use the quality inspection and control method so throughout the machining process. So and the first one is visual inspection. So this is simplest method, and looking at the part for visible defects such as scratch, burst, or surface irregularities, and it usually done after machining and before packing. And the second one is the dimensional inspection. So this is one of the most important step. Tools like vernier calipers, micrometers, coordinates measuring machine (CMMS), and height goggles are used to check the part dimensions. So for the precision parts, CMMS can measure in microns and automatically compare to the part to its CAD model. So and then the third one is the surface finish testing. So a surface roughness tester is used to measure how smooth the machine surface is. So smooth surface are important for moving components or sealing surface. And then and the fourth one is tool condition monitoring. Modern CNC machine use sensor to detect tool wear or breakage. So this helps prevent producing a large batch of defective part. And then statistical process control (SPC). So this method use data and charts to monitor the machining process in the real time. If any measurement goes out of the control limit, adjustment can be made immediately before more defect occurs. So by combination this method, manufacturers can maintain high quality, precision, and customer satisfaction. So let's go to the and lastly conclusion. So machining is a subtractive manufacturing process that remove to material to form precise part, and it's very important in the industry like automotive, aerospace, and electronic due to its high accuracy and versatility. However, like any process, machining can produce defects such as tool wear, chatter marks, burr, and dimensional errors. So to ensure only perfect product reach customer, so quality inspection and control method like visual check, dimensional measurement, and surface testing are used. So in this conclusion, machining remain one of the most essential and reliable manufacturing processes in the modern world. So it allows us to create high quality product with tight tolerances, supporting everything from a simple mechanical tools to advanced aerospace component. So thank you for listening. So and I hope you all know and clear understanding of the machining process and its important in the manufacturing. So